Assalamualaikum and good day, guys. So today we are going to proceed with the second subtopic in Fourier series, which is how to sketch a graph. And based on the graph, how are you going to identify either the graph is odd function or even function or neither function? Okay. So before we can proceed with an example, first you need to know what is the condition for a graph to be an even function or odd function or neither function. Okay. So for even function, your graph should be symmetrical about fx axis. Symmetrical about fx axis. Okay, so when you sketch a graph, so this is your axis, so this is your x-axis, and this is your fx axis. So when we talk about symmetrical about fx axis, so if you have in this side, then you will have in this side. Okay, for example, this one. If let's say you have here, so if you have this kind of graph, okay, this one and another one is here and here. So as you can see, this one is symmetrical to this one, and also this one is symmetrical to this one. Or to make you more understand, if you flip your A4 paper, so whatever you have in this side, you will have in this side. Okay, that is symmetrical about fx axis. Okay, or another example is, if let's say you have this one, if this is your x and this is your fx, and you have this kind of graph. Okay, so this one, let's say this is -1 and this is 1. Okay, symmetrical about fx axis. So therefore, this is an even function. Okay, so what is the condition for it to be an odd function? So for odd function, it should be symmetrical about the origin. Origin, not the x-axis. Okay, two different things. Okay, so if this is your axis, this is x-axis, and this is your fx. Okay, symmetrical about the origin means here, this is your origin. So if you have here, so you will have another one here. That is symmetrical, because symmetrical about the origin, not symmetrical about x-axis. Okay, if symmetrical about x-axis, if you have here, then another one should be down here, isn't it? Okay, but that is wrong. Okay, that is x-axis. But now for odd function, it's symmetrical about origin. So this is origin. Coordinate is 0, 0. So if you have here, then another one should be here. Okay, or same goes if you have this kind of graph. If this is your x and this is your fx. Okay, so if you have something here, so another one should be down here. Okay, then only it will be symmetrical about the origin. Okay, for even function, symmetrical about fx axis. So if you flip the paper here like this. Okay, for odd function, it's symmetrical about origin. Okay, origin, coordinate 0, 0. So if you have up here graph, then you will have down here. Okay, this is the example. Okay, and the last one is neither function. So neither function, if it is not symmetrical, either in not symmetrical at fx axis, on fx axis, or origin, or which mean either this one or this one. Okay, so if let's say you have this kind of graph. Okay, this is x and this is your fx. Okay, so let's say you have this one and another one is this one. So clearly this is not symmetrical, either fx or origin. If you say it is symmetrical about fx axis, so if you have this line here, then therefore you should have another one here. Okay, or if you have this line here, therefore you should have another one here. Okay, then only it be symmetrical about fx axis. Okay, or if it is symmetrical about the origin, if you have here, then you will have another straight line down here. Okay, or if you have a straight line here, then you will have another one here. Okay, but in this case, this is not symmetrical, either fx or origin. So therefore this is a neither function. So now we are going to sketch a graph based on the given function and identify whether the function is odd, even, or neither function. Okay, so let's take a look at the first example. If let's say your given function is fx is equals to x plus pi, negative x minus pi. Okay, this one is from the range of negative pi to negative pi over 2. This one is from negative pi over 2 to pi over 2, and the last one is from pi over 2 to pi. So with this one, fx plus 2 pi. Okay, so for you to sketch the graph, you just have to take a look at the function that have a range. Okay, so you just have to consider first this one, and this one. Okay, this one I will explain to you when we are going to solve Fourier series. Okay, this one is not needed for sketching. Okay, now the question asks you to sketch the graph for the range of x is x for the range. Okay, sketch for the range x greater than negative 2 pi less than 2 pi. Okay, so this is the problem. You need to sketch between the range of negative 2 pi to 2 pi. So as you can see here, first you need to sketch based on the range here. Okay, then only you need to follow this one. Okay, so for you to sketch this graph, you have a function here. So I always ask my student to do this way. So the first one is your fx. Okay, this is your x, which is the range of x, and your fx is equals to x plus pi. Well, I'm considering the first function first. Okay, this one. Okay, so for you to find the coordinate, at least you need to have 2 points. Okay, so the easiest way is by using the upper limit and the lower limit of the range. Okay, so use this one and also this one. Okay, so the first one is by letting your x is equals to negative pi. X is equals to negative pi. So here you have x, so substitute negative pi. So negative pi plus pi is equals to 0. Okay, so another one is negative pi over 2. So negative pi over 2 plus pi. So you will have pi over 2. Okay, so therefore your first point will be negative pi 0. The second point will be negative pi over 2 pi over 2. Okay, so this is for the first function. Okay, so the second function is, by considering your x is equals to negative pi over 2 and another one is pi over 2. So you just consider the upper limit and the lower limit for this function. Okay, so for the easiest way is by choosing this one and this value. Okay, so in this case your fx is equals to negative x. Okay, so if you substitute negative pi over 2 here, then you will have negative, negative, positive, then you will have pi over 2. The next one is, this one is pi over 2, so substitute into here, then you have negative pi over 2. So therefore your coordinate will be negative pi over 2, pi over 2, and the second one is pi over 2, negative pi over 2. Okay, so the last function that you have is this one. For your x is equals to pi over 2 and also pi, and your fx is given by x minus pi. Okay, so when your x is equals to pi over 2, so substitute x is equals to pi over 2, therefore this one you will have negative pi over 2. Okay, and this one here, when your x is equals to pi, pi minus pi will give you 0. Okay, so therefore your coordinate will be pi over 2, negative pi over 2, and the last one is pi and 0. Okay, this one is just a guideline for you to sketch a graph if you are not expert enough. Okay, you didn't have any marks here, just to guide you to sketch the graph. Okay, but if you can just sketch without doing this one, then proceed. Okay, but if you think that you cannot do fast, then do it step by step like this. Okay, so now you already have the coordinate. You have 1 2 3 4 5 6 coordinates, so plot this coordinate on your graph. Okay, so let's consider this one. So let's say you have, so this is your axis. Okay, sorry. Okay, first this is just a sketching. Okay, so it shouldn't be like too accurate. You want to use 1 unit or unit, no need. Okay, so first you need to label first your x-axis and also your f-axis. Okay, so the next step is what you should do, label for your x-axis. So in this case your range is by using pi, so your x and your f(x) is in terms of pi. Okay, so the first one is you have negative pi over 2 and this is negative pi, and this one is pi over 2 and this is pi. Okay, so next plot your function here, your coordinate. So okay, for your f(x) also, start from 0 and you have pi over 2 and this is your pi. This is negative pi over 2 and this is your negative pi. Okay, so the first coordinate will be negative pi 0. So where is negative pi 0? It's here. Okay, the second one is negative pi over 2, pi over 2, which is here. Okay, the next one is negative pi over 2, pi over 2. Negative pi over 2, pi over 2, which is here. Okay, this is number 3. So number 4, pi over 2, negative pi over 2. Pi over 2, negative pi over 2 will be down here. Okay, and the last one is pi 0. So pi 0 will be here. So clearly this one will be equal to, so you have a straight line here and another one straight line here. Okay, now your problem is on how to sketch from here to here. Okay, so here you have a coordinate 0 and 0. Okay, so this is the first one, the second, third and the fourth one. So as you can see here, based on your range here, where is the value of x is equals to 0? It is here, isn't it? Okay, here the value of x is negative pi over 2, pi over 2. So between negative pi over 2 and pi over 2, you have 0. Okay, so for the second function here, when your x is equals to 0, y fx is equals to 0. So you have another coordinate 0 and 0. So 0, 0 is here. Okay, why I need to find this one? Because you don't know how to continue, how to combine these 2 points. Oh, sorry. You don't know how to combine these 2 points. Okay, so that's why you need to have another point here and check. Okay, so therefore when you have your x is equals to 0, so your fx is equals to 0. Okay, so you have a coordinate 0, 0 here. Then only you can combine all these 3 lines. That's it. Okay, you get it? Okay, so why I'm choosing the second function? Because by looking at the range here, x is equals to 0 is in this range. So for this range, your fx is equals to negative x. So that's why I'm choosing this function. Okay, so now this is the original function. Okay, from negative pi to pi based on your range here. Okay, but you were asked to sketch from negative 2 pi to 2 pi. So you need to have until 2 pi here. Okay, so if this is pi, so 1 here pi plus half, so you will have 3 over 2 pi here. Okay, so the range will be 3 over 2 pi plus 1 over 2, then you will have 2 pi here. Okay, so same goes for this one on your left hand side, so you will have negative 3 over 2 pi, negative 2 pi. So how are you going to extend your graph based on this original one? you do need to substitute again your x is equals to negative 3 over 2. No, you just need to repeat your graph. So now by looking at your original function here, you have three functions. Okay, so I label it as, so this is your first function, this is your second function, and this is your third function. So 1, 2, 3. So you need another 1 here, isn't it? So therefore you will have another straight line here. So the graph will repeat itself after a certain period of time. So here, this is your original graph, which is this one, x plus 2 pi. So from here to here, okay, this is your original graph. So now the graph will repeat itself after this point. Okay, so you have 1, 2, 3. So we start again with 1. So your 1 will be up until here. Why here? Because you have here. Okay, so you need to have the same fx. Okay, and the same range for x. This is half, so therefore you just need to move half here. Okay, so the second one is this straight line. Okay, and as you can see, this straight line touch the axis here, the point 0, 0. Okay, so therefore you will have this one, here. Okay, why I didn't continue? Because if I continue the straight line as this is this one straight line here, if I continue here, so this one will approach more than 2 pi, so that's why we stop until here. Okay, so now done with the right hand side. So for your left hand side, it's a reverse function. Okay, so reverse process. So this is 3, 2, 1. So you need to start from 3. So your function for number 3 is down here. So therefore, you will have a function down here. Okay, and the next one is number 2. So up here until pi over 2. Okay, but this one we just want until negative 2 pi. So we just have to stop until here. Okay, until this point. Okay, when you extend your graph, it's not necessarily for you to have a complete graph. Okay, it depends on your problem. Okay, so how are you going to identify whether this is an odd, even, or neither function? By looking at the original graph here. So as you can see here, this graph symmetrical about the origin here. This is the origin. Okay, symmetrical about origin. When you have, so this is your point for origin. So when you have here, then you will have another one here. Okay, and you have a straight line here, and you will have another one here. Okay, so therefore this is an odd function. Why? Because this is symmetrical about origin, about the origin. Okay, odd function because it is symmetrical about the origin. So now we take a look at the second function. Okay, second function where your fx is equals to, so problem number 2, your fx is equals to negative x minus pi 3 pi. For the range x is greater than negative pi less than 0, x is greater than 0 less than pi. For x plus 2 pi. Okay, and you were asked to sketch between the range x greater than negative 3 pi less than 3 pi. Okay, so how are you going to sketch this function? So as you can see here, this is a constant. Okay, this one here you have variable x. So when you have a variable x, then you need to do this table, okay, for you to know the coordinate. Okay, but if you have a constant, you don't need to do anything. You just, because when you have a constant, you know that you will have a straight line. Okay, so that's why you don't need a table. You don't need to do this table. Okay, so for the first function here, your x is negative pi and 0. So negative pi 0. What is your fx? Negative x minus pi. Okay, so substitute negative pi here. So negative, negative, positive. So pi minus pi is equals to 0. Okay, substitute x is equals to 0 here. Then you will left with negative pi. So therefore, your point is negative pi 0, 0, negative pi. Okay, for the second one, between x is equals to 0 until pi, the fx is always 3 pi. So you will have a straight line. So therefore, you need to sketch the axis first. So you will have okay, so this is your x and this is your fx. So as you can see here, they are using a range 1, isn't it? 0, pi, 2 pi, 3 pi, because this one the gap is 1. Okay, but for the previous function, this is half. Okay, that's why your graph, your axis, you will have half pi, pi, 3 over 2 pi and 2 pi. So how are you going uh, to know whether you want to use half or you want to use pi, 2 pi or 3 pi? It depends on your problem here. Okay, so for this case, you will have pi, 2 pi, 3 pi. Why I stop on the 3? Because you are asked to sketch from negative 3 to 3. Okay, so for your left hand side, you will have negative pi, negative 2 pi, negative 3 pi. Okay, and here you have negative pi, negative 2 pi, and for your fx, you have pi, 2 pi, 3 pi. Okay, so now we are going to sketch. Okay, so your first point is negative pi 0. Where is negative pi 0? X is equals to negative pi, y is equals to 0. Sorry, fx is equals to 0. So it is here. Okay, another one is 0, negative pi, which is here. Okay, so you know that this one, if you combine these 2 points, you will have this straight line, this line. Okay, so for the second function, from 0 to pi, this is 0 to pi, your fx is always 3 pi. So therefore, you will have a straight line here. Okay, from 0 to pi, your fx is always 3 pi. That's why you have a straight line. Okay, so therefore, when you have a constant, you don't need to construct this table. you can straightly sketch because it's just a straight line. Okay, but if you have variable x, so the function will change according to the value of x, so that's why you need to have this table. Okay, so label your function. So this is your first function and this is your second function. So now the function repeats itself after pi. Okay, there is 2 pi here, from here to here. This is 1, this is another 1. That's why it is 2 pi. Okay, so now the function repeats itself after this period of x is equals to pi. So now it repeats until negative 3 pi to 3 pi. Okay, so if this is 1, 2, so again you need to start from 1. Okay, so you will have another point here, another line here, which is this one down here. Okay, so you will have the same. Okay, you need to stop here. Okay, so this is the first one. So the second one is your straight line. So the straight line is from here until 3 pi. Stop. Okay, so this is 1 2 1 2. Okay, settle for the right hand side. So for the left hand side, so this is number 2, this is number 1, so we will start with number 2. So therefore you will have another one here. So the gap is from 0 to pi, which is 1, isn't it? So here from negative pi to negative 2 pi. So you will have a straight line. Okay, and the last one is this one here. So down here and here. Okay, and stop. You need to have so that the value of x is fx is the same. Oh, sorry. This is here. So this is your okay. Okay, done. So as you can see here, there is no gap between the original graph and the graph that repeats after that. Okay, as you can see, we stop here, then we go down here and we start with the repeated one. Okay, and the first one is stop here, so the next one is from from 2 pi to 3 pi, so it is here. You don't need to have this dotted line. I just show to you there is no gap. Okay, when you stop here, so you will start with the same x. Okay, because a few students, when you stop here, you start from 2 pi. That is wrong. Okay, because this is a continuous function. Okay, so same goes for this case. Start from negative pi, and you know that the second function with a gap 1 here, so negative 2 pi to negative pi, so the function is always 3 pi. So you will have a straight line here, Okay, so by looking at this graph, this is clearly neither function. Why? Because it is not symmetrical, either about the origin or fx. Some student might say this is an even function because you have this side and this side, but that is wrong. Okay, this is not symmetrical. If you have this one here, for you to be symmetrical, then you need to have right here another one. Then only it be symmetrical about fx. Okay, so if you have here, then you will have another one here. Then only it be symmetrical about the f(x) axis. So for this case, this is a neither function. Why? Because not symmetrical at origin or f(x) axis. Okay, so in my next video we will proceed with another few examples of how to sketch a graph. Okay, so stay tuned and see you in my next video.